Let's go ahead and look at our two examples for the 5 types of sampling. All right, so these are not necessarily going to use all 5, all right? On MyOpenMath, it's the same case. You have a drop-down menu and you are picking which type of sampling you think it is doing. All right, here we're talking about a study that's done to determine the average tuition that San Jose State undergraduate students pay per semester. Each of the following samples is asked how much he or she paid for fall semester. So each person in the sample is asked this question. What type of sampling is used in each of these cases? So this is how we collected the students that we are then asking the question to. A sample of 100 undergraduate San Jose students is taken by organizing the students' names by classification, so freshman, sophomore, junior, senior, and then selecting 25 students from each. All right, note that we're talking about a classification. This is a grouping. So we broke into 4 groups. So it's automatically going to be either stratified or cluster because we're starting the process by talking about a grouping. All right, from the groups, we take 25 students from each. So we're taking some from each of the groups. That was going to be our stratified. All right, I'm going to actually write them off to the left to help us keep track. This is going to be stratified. Sorry, I didn't leave you a blank space to write your answer in. All right, stratified sampling. Part B, we have a random number generator that's used to select a student from the alphabetical listing of all undergrad students. Starting with that student, we are taking every 50th student. Okay, so yes, it started with a randomized list, but it's not like we're just taking 50 or 75 students at random. We are taking from that random spot every 50th student. So from our list, we pulled one, we went 50 students later, we pulled that name, we went 50 students later, we pulled that name. This was our systematic, all right, like the assembly line. Systematic. Again, I really apologize if any of this is ever spelt wrong. I'm going to say that in every video this whole semester. All right, systematic sampling. Part C, we have a completely random method. It's used to select the 75 students. Each undergrad student in the fall semester has the same probability of being chosen at any stage in the sampling. Simple random sample, all right? The way to think of these is it's completely randomized. It's like drawing names from a hat. That's going to be our simple random sample. All right, part D, the freshman, sophomore, junior, and senior years are numbered 1, 2, 3, and 4, respectively. A random number generator picks 2 of those years, and all students in those 2 years are in the sample. Again, it begins by talking about those 4 groupings, the classification, then 2 of them are randomly chosen, and all of the students in those 2 are picked. This was our cluster sample. And finally, an administrative assistant is asked to stand in front of the library one Wednesday and ask the first 100 undergrad students he encounters what they paid for tuition. Those 100 students are the sample. This is, you could have guessed it, convenience. All right. These students are all at the same place around the same time. So again, they could share some very common characteristics, maybe really good studying habits. Maybe they all are taking in-person classes, or I guess they're not necessarily. They're all on campus at the same time. All right, so it might not be representing the population as a whole because they're already sharing some characteristics. I'm going to go ahead and go into the next example in this one video. Sorry if it gets a little long. Maybe we'll work through this one a little quicker. Again, determining the type of sampling that's displayed. We're not necessarily talking about the same example in this or the same situation in this example. It's going to be different pieces. A soccer coach selects 6 players from a group of boys aged 8 to 10, 7 players from a group of boys aged 11 to 12, and 3 players from a group of boys aged 13 to 14. All right, so a little different, a little more abstract here, but we already see that there are groupings of ages. All right, so 11 to 12, 13 to 14, 8 to 10. All right. And he's selecting some from each of these groupings. It's good to say, or I would assume that this is stratified. I suppose we could ask for a little more information if these were the, if there were more groups and these were the only people from these groups, then it could be cluster, right? If there was a group from 6 to 8 that we didn't mention, and also a group from 15 to 17. Just for reference, if I ever were to ask you one of these questions, I would make sure to specify that these are the only ages and we are selecting some from each of them, right? So it is stratified. If I ever don't mention something like that, you can argue your point, all right? If there is wiggle room in those situations. All right, a pollster interviews all human resource panel in 5 different high-tech companies. All right, again, a little wiggle room here. This one was meant to be a more challenging problem, not as straightforward. Here we have all human resource personnel in 5 different high-tech companies. So it's easy to assume, because it says all human resource personnel, that there are more than the 5 high-tech companies, that we've randomly selected 5 of the companies and we are interviewing all of the people in those 5, which is going to make this a cluster. All right, a high school educational research interviews 50 high school female teachers and 50 high school male teachers. We are assuming for this that there's not a third grouping, okay? If we're taking all the high school teachers, we're splitting them into male and female, whatever they identify with, male or female. All right, so this is going to be stratified because we are splitting into 2 groups and we have 50 female, 50 male. It's some from each of the groups. A medical researcher interviews every 3rd cancer patient from a list of cancer patients at a local hospital. Every 3rd patient. Looking at the list, we pull one, 3 names later, we pull another, 3 names later, we pull another. This is systematic. A high school counselor uses a computer to generate 50 random numbers and then picks students whose names correspond with those numbers. So the random number generator gives it very randomly. We pull the names associated with each of those numbers. This is a simple random, all right? Probably the easiest way for us to actually do a simple random sample, all right? Especially if we have some kind of list that is ordered. Computer random generators will do that randomly for us. A student interviews classmates in his algebra class to determine how many pairs of jeans a student owns on the average. Like my example earlier, we are just asking the people around us because that is very convenient for us to do. This is an example of convenience sampling. All right, we made it. Thanks for sticking with me.